we're going to jump right into the console here and just get started. If this is your first time sort of being involved with AWS, a couple of things to remember. You should not use your root credentials at all. Once you've created your account, you should set up a strong passphrase, not just a password, a phrase of several words together, and maybe some numbers and characters included in that. Set up multi-factor authentication, and then store that away somewhere secure, and then set up yourself with a user and a role. So we don't use the root user. We're going to set up an admin user for admin tasks, and then we're going to only use that root user when we need to sort of self-rescue if there's been some kind of error or mistake that you've made with your permissions, or otherwise you will need to raise a support ticket to get around this. So your VPC is basically a walled garden in which you can put your compute, optionally your Lambda as well. ECS containers can go in there, and EKS as well. So when we're using a VPC, we want to sort of isolate our compute away from the rest of the world and expose only the bits and pieces that we really want to. And it's also a good idea to set up a segregation into tiers of usage when it comes to provisioning your resources in a VPC. So I'm going to jump across to the VPC console directly here. So I'm in the US East 1 region, North Virginia. And I'm going to open up the VPC screen. And you can see in this one there is a default VPC. Dead giveaway, there's no name. It's a short string. Normally this is about twice as long for the ones that we'll be creating. And this IPv4 CIDR block is a 172.31/16, which is the default VPC range. There's a couple of reasons why you might want to use a custom VPC over the default one that AWS give you. The first one is that obviously maybe we don't want to be using the default range. Maybe we want to use something custom. If you decide at some point later on you want to have more than one VPC, that these CIDR blocks need to be different to allow them to be connected together. If you've got the same range, then you won't be able to route traffic between them. The tagging that's set up in this isn't really sufficient. We would like to be able to have our own range. We would like to be able to set up and turn on VPC flow logs. And we also want to have a specific network access control list and set up our route tables, Acls, and custom CIDR blocks. I've created this draw IO diagram to try and help to explain a little bit better about how this works in practice. So what we can see is we've got our AWS cloud, and then we've got our AWS region. So the region is AP Southeast 2 Sydney, and inside of this region we've got a VPC. So our VPC, in this case, I'm going to call my VPC Thomas VPC. And in this VPC, we can see that on the boundary, we've got an internet gateway set up. So inside of our VPC, we've got 3 availability zones. But those availability zones aren't exclusive to my VPC. That's why they sort of hang out the side and hang at the bottom as well, because they're not exclusive for my use in that VPC. They're also usable across several VPCs. So inside of those availability zones, we can see we've got a public subnet tier, a private subnet tier, and a database subnet tier. We've got on the left-hand side, we've got a network access control list and a route table on each of those subnet tiers. So they've all got 3 separate ones, and that covers the entire database subnet, the entire private subnet, and the entire public subnet. The way that each of these are configured will be a little bit different, and what you'll notice as well that on the far right hand side over here we've got 3 extra subnets that are red that aren't inside of any of my infrastructure here. Now, why would that be? It's the nature of a /22 when you have a /22 CIDR block that it encompasses 4 sequential addresses. So in this case, it's the 0, or beg your pardon, 10.10.0, 10.10.1, 10.10.2, and then over here we've got the 10.10.3. We don't have a fourth availability zone in this region, so we're not going to allocate this 3 here, and what we're going to do is we're just going to skip over that one, not create it, and go straight to the 4. That way we can describe our entire subnet tier of private, our entire subnet group of public, and our entire subnet group of database in one neat/2022. So we can say we only want the database tier talking to the private subnet tier, and we can just tell this one, you're only allowed to communicate with the 10.10.4/22, all this address range, but nothing else. And that allows us to very, very neatly encapsulate the access control lists and the route tables and everything we like as we need to. So that kind of explains why I've got this out here on the fringe. That's not going to be used and it won't be created. We're just going to ignore that entire 3, 7, and 11 block. So inside of the public subnet tier, we can see we've got 10.10.4.0/22, meaning we want to be able to access the private tier from the public tier. So we want to be able to get into this private tier from the public tier through our routing, which will be set up on the network access control list and the route table, which will allow us to traverse into that subnet. But what you'll notice is there's no route to the database tier from the public tier. We're only allowing to the 4.0/22 range. And then we're also allowing a 0.0.0/0 here, which is our allowance to go out of the internet gateway. So we're going to attach an internet gateway to access the public subnet, but not the other 2 subnets. And we're going to give a route and a network access control list rule to allow us to go out of this through the route table, through the access control list, and out to the internet gateway to the public internet. What you'll also notice here is that in our VPC on the availability zone B is that we've got our public subnet 10.10.1.0/24. We're going to allocate a Nat Gateway in here. So this icon is a Nat Gateway icon. And what this is going to allow us to do is we're going to be able to create an item in the route table for the private subnet group to say, if you want to access the public internet with your private address, so all of the instances that will be created into here will they'll each have a private address. So if an instance gets created into the subnet C, then it's going to have an address of 10.10.6. something in that range of the last octet. So if we want to be able to have this instance go out to the internet and update itself, our route table here is going to need some way of telling anything in this group that, hey, I want you to go into the public subnet, but I want you to access this Nat Gateway first, and the Nat Gateway will then release you into this public subnet, and the public subnet route table will route you out the internet gateway. We do not want anything in this subnet directly accessing the internet gateway because it's the private subnet. So what we'll do is we'll set up a rule on the private subnet to route traffic down to the public subnet into this Nat Gateway, and the Nat Gateway will then push us back out the internet gateway. So also at this point, if you wanted to have some kind of internal private connectivity externally, you might not allocate an internet gateway here. What you might want to do is you may want to allocate a virtual gateway or a transit gateway on the fringe of your VPC to be able to access other VPCs or other network infrastructure. So to expand on our conversation earlier around the idea of using NAT gateways and the high availability use of NAT gateways, what we can see here is we've deployed a NAT gateway into the public subnets for A, B, and C availability zones. So to be able to make this work from the private zone into the public zone, we've got to set up a route table per subnet in the private zone so that we can stipulate that we want to have traffic routing to the specific public subnet, but then also back to the entire database subnet on each of the the private availability zones that we have here in this image. So the access control list can remain the same, but it's important that the routing does carry through to the same Nat Gateway that is set up for each availability zone to work. And an important consideration for using a Nat Gateway is that they do cost money to run. So if you're going to provision a Nat Gateway into your VPC, there is a cost to run these at all times. So I would highly recommend, if you're going to do this as your own, you're in your own VPC as a part of this lab, that when this is done, that you shut down each of these NAT gateways and then destroy them, and also release the elastic IPs that are associated with them. The elastic IPs themselves don't cost money to use when they're associated with something that's being used, like a NAT gateway, but once the NAT gateway has been released, there is a cost associated with keeping an elastic IP unused on your account. So that's really something worth thinking about. The rest of the infrastructure you can see on the screen is actually free to run. So you can set this up on your account otherwise, and then just have that sitting there for use as you require in future. One important consideration about shutting down the NAT gateways, though, is that you will need to make sure that you adjust your route table to route out to the public internet, probably, if you wanted to be able to update the instances that are there. As if you just have routing into the public subnet, there will be no way for you to get out to the public internet to update anything in this area. There's a bunch of ways to get around that, but in the interest of costs, I do recommend that you remove your NAT gateways once the lab is complete. We won't be deploying highly available NAT gateways. We're just going to deploy the one in the B availability zone. We're now back in Sydney, and you can see from the drop-down menu here, we've got Asia Pacific Sydney, AP Southeast 2 selected. So we're now going to create that network architecture that we've just examined. And a note about this video, we would never do this in real life. This is just a walkthrough. Normally, I would do this in something like Terraform or CloudFormation. This new VPC will give us the flexibility that we discussed earlier with being able to control access to each of the tiers with the network's access control list and the route tables. This is meant to be illustrative at this point, and maybe another time we can go about building something more specific for a use case. This will be quite verbose in the creation of this VPC, and it's supposed to get you familiar with the tools that AWS provide you. If you're familiar with how this works already, then maybe this is your cue to skip ahead for the rest of this section. And for those of you who want to build along, let's get into it. So what we're going to do is we're going to jump across to the VPC console from the AWS management console, punch in VPC, and we'll jump across here and have a look. So I'm going to select the VPC section, and you can see here that I've removed my default VPC from this region, and also all of the other accompanying things that go with that have also been removed at this point. So what I'm going to do is I'm going to go ahead and create a VPC here. I'm going to call mine Thomas-VPC, and this is going to be a 10.10.0.0/16. All the other settings are fine as they are, and we'll just jump right into that, and that's created our VPC. What we'll notice here is that we've got a default DHCP option set up already using the AWS DHCP service. So we're just going to leave that as it is. We've got a route table, and we've got a network access control list that are set up by default. These are supposed to cover the entire VPC, but we're going to configure 2 more of these and 2 more of these to get everything as we like it. So we'll jump across to subnets now, and we're going to create 9 subnets to support our 3-tier architecture. So right off the bat, we're going to choose the VPC, and we're going to call our first one public-A, and we're going to set that in the A availability zone with 10.10.0.0/24. Cool, and we'll create that, and we'll do this 2 more times for the public area. Public B in the B availability zone 10.10.1.0/24. All of our subnets will be /24s. Create another subnet, choose the Aws Vpc. This is going to be public C, I think we're up to now, and then we'll choose C 10.10.2.0/24, and that's fine. So that's our 3 public subnets configured. Now we're going to set up 3 private subnets. So you can see we've got 0, 1, and 2. We're going to skip 3, and we're going to go directly to 4, so that tessellates with our /22 CIDR blocks for our Acls later on. So again, same deal. This time it's going to be private A in the A availability zone with 10.10.4.0/24. Create, choose the VPC 10.10.5.0. Whoops, that doesn't go there. This is private B in the B availability zone 10.10.5.0/24. And then we'll do the private C in the C availability zone 6.0/24. So that's all of the private A, B, and C setup. And now we'll do the database tier. Same deal again, choose the VPC. This will be DB A in the A availability zone 10.10. And this time we're going to go directly to 8, and we're going to skip the 7. So once again, these CIDR blocks won't necessarily share the exact same availability zone that it says here. So this is AP Southeast 2A. But if you take careful note here, you can see the ID is APSE2 AZ3. And AZ3 is not the same as A. So if you need to have your instances in the same availability zone as a specific other VPC that you might peer with later, then this is the giveaway here, this AZ3. The setting here that's set to A is an arbitrary selection from Amazon. So we'll create that one. That's the A subnet created. Go ahead and we'll get DB B in the B availability zone at 10.10.9.0/24. Create. And the last one, choose the subnet, DB C in the C availability zone for us, and we'll create that. Oh, wait, 10.10.10.0/24. Cool. So now we should have all of our subnets created. Database tier, private tier, public tier. Perfect. 0, 1, 2, 4, 5, 6, 8, 9, 10. Okay, so now that we've got all of our subnets created for all 3 tiers, now we're going to move across to the Internet Gateway, and we're going to create an Internet Gateway in here. We'll call this one Thomas-IGW. That doesn't require any configuration. It's already highly available by default. All we've got to do is attach it to our VPC. We choose the menu and we get our available VPC there, and we'll just attach that gateway. And that's that. So now we've got Internet Gateways attached, so we've got to wait to the internet. One of the other options at this point, if you didn't want to have direct access to the internet and you wanted to attach your VPC to say, for example, another private VPC that you had a part of a corporate network, this would be a time where you would not choose an internet gateway. You wouldn't attach this here. What you would do is you would choose something like a transit gateway, or perhaps you would use a virtual private gateway, something of this nature, to get your connectivity to your other parts of your business. But the internet gateway is the magic that's going to give you a route out to the public internet. So with that out of the way, what we're going to do is we're going to give ourselves the option to be able to use a Nat Gateway here so that we've got access for our private servers to access the internet. So basically, I still want to be able to update the servers that are put in the private zone with updates that might be available out on the public internet for things like Nginx or HTTPD. We might need updates, or we might want to update some of the other packages or the kernel or something like that. So we can allocate these instances with just a private IP address, and that private IP address can then traverse through a NAT gateway. It will be allocated the public IP address of that NAT gateway. It can go out to the internet, get what it needs, and come back with that traffic. Public traffic will not be able to traverse back in through that NAT gateway. Any traffic that you want to have that needs to get access to those servers externally will need to do so transiting through the public subnets. So we'll jump across to the NAT gateway section here. We can see some of my earlier mistakes and errors that I've since removed. Points in the chat below if you can work out how many times I did this before I managed to get it right. So when it comes to NAT gateways, we're going to only allocate one NAT gateway at this point. I'm just going to call this NAT GW. And we're going to choose one subnet. This goes into a public subnet. I'm going to put this in public B. And it's going to get public accessibility, and we're just going to allocate an IP address to it from the Amazon pool, and we're going to create this NAT gateway. Now, with this NAT gateway, there's only one of them set up on the public B subnet, and if we wanted to have this set up in a highly available way, so there was one NAT gateway on each of the public subnets, we could do that, but the only caveat really is that in the private tier, each of those private tier subnets needs to have their own route table. We're only going to allocate one route table for the whole tier, just in the interest of simplicity. But if you wanted to, say, have a highly available NAT gateway, so in case one, the one subnet of your NAT gateway went down for whatever reason, your private tier instances would then lose that ability to go external. But if you need it highly available, then what you would do is you would attach a route table to all of your private subnet tiers, and then each of those would have a route that would go back to their specific availability zone NAT gateway from there. But we're going to skip that one at this point. So we're going to move across now to the route tables and configure that for our usage now. So we've got a default route table set up for us when we created our VPC in the beginning, and we're going to edit this one to become the public route table. Let's call that public RT, and then we're going to come in here and we're going to see that we've got a subnet associations tab here. We're going to associate this route table, this public route table, and we're going to associate that with the public tier. So we're going to, you can see all the unassociated subnets down the bottom, and we're going to edit the associations here and grab all of the public ones. Public, 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 and we're going to save associations. So the next part of this is we want to edit the routes. We want to be able to set this so that we also have a route to the public internet, and we're going to set the default route, and we're going to choose Internet Gateway and choose our Thomas IGW Internet Gateway we set up earlier, and we'll just go ahead and save that. So that allows us to get public internet access. We're going to go back to the route tables. We're going to create two more. This one's going to be private RT, and we'll create. And then we'll go in and create one more. We'll call this DB RT, select the right VPC and create that one. So same again, we're in the database route table now. We're going to create a subnet association with the database tiers, so DB, 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 and that's perfectly fine as it is for its routes. And then we're going to go back to the private route table, and we're going to associate its subnets for all the private tier. So private, private, private. And then for the route, we want to be able to have any of the instances deployed in this zone to be able to route out of that Nat Gateway we made earlier. So we're going to, again, select the default route, and then we're going to go to the Nat Gateways, and we're going to choose this Nat Gateway we deployed in the public A zone. So any traffic leaving our VPC is going to traverse this Nat Gateway in public A, and it will have a route out to the public internet from the public subnet. So we'll save those changes. And so that's the networking portion of our VPC configured correctly, but we still have to set up the network access control list here so that we've got an ability to sort of have some policy over what can come in and out. So we'll switch over to the network ACLs. In here, we can see that our NACL is associated with all of our subnets. So we want to fix this up. So first of all, we're going to rename this to be public NACL. We'll save that one. And then we'll create some other ones. So we'll do private NACL, set the VPC. Oops, that's a typo. Yep, and one more for the database tier. Choose the VPC and create. Okay, so we'll go to the database NACL, and then we're going to set the subnet associations with DB, DB, DB. And we'll come back to the configuration shortly, and then we'll go to private subnet associations. We'll edit the associations here, and we'll go private, private, private. Save those associations. So now we've got 333, that's all set up correctly. All right, so now we want to set what we want to allow in and out of this. So with the public NACL, the inbound rules on this is basically we're going to just allow everything at this point. Now, for sure, we should examine this a bit closer if we were going to do something in production here, but for the purposes of this is going to be close enough. We don't want to get too caught up into the rules. It's just a demonstration, especially for the public subnet. The private subnet, what we're going to do is we're going to edit the rules here, and we're going to add a new rule. These rules are evaluated from the numbers that are associated with the side here, and they're evaluated in order, ascending. So for our private subnet, we want to basically set an allowance of HTTP. We'll start with SSH, but we only want to allow SSH from the 10.10.0 space, and we'll set that as a 22. And then the next one we want to do is we want to have a 101, and we'll set this as HTTP, and we'll copy this one over. And then we're going to also allow our HTTPS. So this is just simplistic demonstration, and we can sort of mess around with this a little bit. For the outbound rules, we do need to set identicals the other way around. So we're going to add these rules, and actually we also need to set the ephemeral ranges as well. So we'll set those as we go. So we'll just go 100, 101, 102. Okay. So in here, we're going to do port 22, port 80, port 443, and then we're going to do a custom rule for TCP and a custom for UDP. And this will be 1024 to 65.535 which is the ephemeral ranges that we want to be able to have access to across here. Okay, and we'll update that on the inbound rules too. Okay, so that's private, and then on our database tier, we're going to edit the inbound rules here. I'm going to add 2 rules here, and the rules are going to be custom TCP, custom UDP. This will be 100. This will be 101. And we're going to set the same ephemeral range because all of our database ports that we're planning on using are going to be inside of this range anyway. But importantly, we're going to set 10.10, 10.10, and what we're going to have here is we're only going to allow traffic from the private subnet tier on a /22. So this will only allow traffic from our private subnet to be able to access it, and only in the ephemeral range. So we'll save that. We'll do the same thing on the outbound rules. Add 2 rules in, 100, 101. Change this one to custom UDP, set the ephemeral range, then we'll set this to /22s, and in our correct ranges. Cool. So we've got the database tier in and out set up. We've got the private tier set up. Actually, we don't. Yeah, we do want that. That's fine. And actually, I want to edit that. This one needs to also be configured to only allow traffic in from the private, from the public tier and the database tier. So what we need here is a /20, /20, /20. Okay. That's wrong. Okay, so I think that should be okay as it is. Just like that. If it's not, I don't, like I say, I don't want to get too caught up in the rules. It's just a demonstration at this point. If you can point out anything that's wrong here, then yeah, go ahead and put it in the comments. But like I say, this is just illustrative at this point. So once we've got the Acls set up, so we've got everything set up as we need to, that's pretty much as far as we've got to go with this. So I guess what we could do at this point is we can go into EC2, and we could probably just start an instance up into the public tier and then just see if it's accessible. So let's just launch an Amazon machine. In our VPC, and I want to put this into public B is fine. We want to enable a public IP. And I'm not going to worry about roles for now. We don't really need it as far as we're doing here. We'll just go to the next part. That's fine. So with tags, if you set a name tag, it actually gives it the name of that. And then we've got the instance name, the volume name, and the interface name will all get that same name. I want to actually allow, I'm just going to allow everything at this point, just because I'm going to shut this down basically immediately after I set it up. But I'm going to say, actually, I'm just going to leave that, and that's fine. So, and that looks good. And we're just going to go ahead and launch this. I'm not going to worry about using a key because I'm not planning on actually joining this machine. It's for another demonstration. So we're going to jump across, look at our machine. You can see the public IP that we've been allocated from the Amazon pool is right here. So for this demonstration, what I want to use is not necessarily that I want to actually connect to the machine itself. I just want to demonstrate that there's connectivity available to us. So what I'm going to try and use is Netcat. So Netcat's a nice networking tool which allows us to be able to try and see if there's a network connection over the internet with a port without actually having to connect to it. It does a bunch of other really cool things that we'll probably end up covering later on, but for this point, what we're going to do is we're going to nc-vz, and then we're going to give it the IP address, and then I'm just going to see if port 22 is listening, and we can see that the connection would be a success. There is something listening on the other machine. And that about wraps up as far as we're going to go with this demonstration. Thanks very much. So thanks very much for making it this far through. Now, the last thing that remains to be done now is we're going to deallocate our Nat Gateway in our B availability zone. Once that's been deallocated, you may want to update your route table for the private subnet tier so that it no longer points towards the Nat Gateway, rather it has an allowance out to the Internet Gateway. Or, and then if you have an allowance to the Internet Gateway, you then want to also just make some allowances in the network access control list for the things that you want to be able to access over that route. Otherwise, you can just have an allowance to the public subnet tier and then just have it locked down as you need to. But I do highly recommend shutting down this Nat Gateway. And then once the Nat Gateway has been deleted, then you need to go into the Elastic IP section of your AWS console and the EC2 console and then release that Elastic IP back to the AWS pool, or it will cost you money to have that. And so thanks very much for joining. Have a good day.